Uh, thank you for inviting me to the winner's call. Now present the second place solution. My name is Shunsuke Toba, and username is called Shunpi. And uh, I work as an AI engineer at a real estate startup company in Japan. I regularly participate in competitive programming, and particularly in heuristic contests, which involve optimization problems. And this experience has been particularly useful in this competition. Next, please. I will explain the summary of my solution. Uh, in my solution, subquery candidates are generated and evaluated, and then joined with OAuth to create a query like this. Also, for some queries, negative subquery, this means not negative subquery 1 or and so on, is used to increase the score very slightly. And each subquery and negative subquery is several was connected by AND operation. And there is a magic which can be AND joined without white space. So each subquery fits into one token like this. Next, please. And due to the nature of the evaluation score, it is very important to ensure that non-targets are not included in the query results. To ensure this, I wrote a custom search algorithm that executes each query for all patents. Next, please. Next, I will focus the key ideas of the solution. The evaluation score of this competition has the nature that query results that do not include non-targets will have significantly higher scores. And this figure shows that expected value of evaluation score calculated for each of the number of targets and the number of non-targets. For example, 49 targets and one non-target, and 41 targets and 0 non-targets have almost the same score. This means that the value of 5 targets and the loss of one non-target are almost same in this aspect. And according to the Bush docs, the order of query results is ordered using TF-IDF scores, but it is difficult to control. So I calculated the expected value by assuming the order of the query result is random. Next, please. Next, probably I guess test index intentionally contains non-targets that are similar to target. This figure shows this idea. This can be get from the fact that when you submit the solution using a query that may include several known targets, you get a large CV-LB gap. For example, CV is 0.8, but leaderboard score is 0.5. Therefore, it is good and important to use all patents to ensure that the query results do not include non-targets. However, it is difficult to build WHOOSH with all patent data, so it is necessary to build my own fast algorithm. And next. And, and, and the magic of being able to do and joins without white space. And this magic is extremely important for score improvement. For example, if all the words in a patent are joined by and it is almost certain that only that part is patent is retrieved. Then if one token can retrieve one patent, 25 targets, this is equivalent to 0.84 in the score, can be achieved just by joining 25 talks by OR. And this upper right figure shows this solution. And next, if two targets can be retrieved with one token, it is possible to achieve 50 targets, equivalent to one perfect score, by joining 25 tokens by OR. And this idea is the basis, the most important aspect of my solution. And right, 右下、右下ってなんていうの？right bottom figure is shows this solution. Okay, next please. Next, I will explain the solution. In the final solution, the query looks like this. Here, subquery and negative subquery is several words joined by AND operation. Negative subquery is used to cancel out the non-targets that appear in subquery. Using negative subquery improved the CV by about 0.0002. Next, please. The process is divided into three main parts: constructing index, generating subquery candidates, and selecting a subquery to use in a query. The right shows the pseudocode for the entire process. First, constructing index, and next, for each test row, generate subquery candidates, and for each subquery candidate, get the score of candidate, and the maximum score is used for query. Finally, query is joined by OR. And for time and memory efficiency, all the following solution methods are implemented in C++. Compared to the Python, it is about 5 times faster in time and 3 times more efficient in memory. Next, please. The next 3 slides shows a description of my algorithm, but I will not provide a detailed explanation due to time constraint of this presentation. So first process is constructing index. Convert all patents and words to integer IDs in advance. In the left figure, P1, P2, P3 represents patent ID, for example, US1A. And W1, W2 represents word ID, for example, title system. As shown in the left, make a two-dimensional list from each patent word and each word to each patent. And since the data for claims and descriptions columns is so large that it can't be stored in RAM of Kaggle notebook, so I deleted words with high frequency of occurrence and reduced the data volume to 13% for claims and 1.5% for descriptions. Next, please. The second process is generate subquery candidates. Create subquery candidates corresponding to 50 single target and 1,225 target pairs. And in this way, this process makes it possible to obtain the string for each query, each subquery, and the results of the subquery at the same time. And the procedure in C is important for reducing execution time, since the intersection set calculation takes the minimum of length of two sets. So the shorter set calculation should be earlier in this calculation. Next, please. Final process is selecting a subquery to use in a query. For each candidate, the number of new targets to be covered is evaluated as a score, and the subquery with the highest score is added to the query. And if there are the same number of the score is there are the some targets with the same score, and the second the second of this the second term of this score function is used for tie breaking between targets. The more difficult target to a more difficult a target is to cover, the higher the score when it is covered. Next, please. This figure shows the histogram of the number of targets that could be retrieved in the final submission. About 91% of the data gave a perfect score, 50 targets, and about 99% of the data gave more than 45 targets. Next, please. So finally, I will explain solution without magic. My solution without magic gets the score with 0.904. It is almost the same as with magic. The only difference is the use of white spaces in the underjoin, and the counting of the number of tokens has been changed accordingly, like this. I guess it would be possible to improve the score by nesting the parentheses by the common word, and this reduce the number of tokens. Next, please. That's all for my presentation. Thank you for your attention.